So the next type of collection that we'll cover is stack. So stack is something like this, right? This is a stack of pancake. Here, the driving principle of stack is last in, first out. What it means is the pancake that you had made and at the first goes at the bottom, and the most recent one that you made is on the top. And when you start eating it, you start removing it from the top. So whoever comes last goes out first. That's called a stack. Now let's see how it actually works in C#. So here, if you see, when you create a stack, it creates an empty stack. There are no elements in it. Now, the operations that stack supports are push and pop. These are the two main operations that the stack supports. By push, you push an element into the stack. Now it has one stack element here. When you push 2, 1 goes down and 2 comes on top of 1. And same when you do 3. So when you have pushed all 3 elements, this is how your stack looks. Now when you start popping from the stack, 3 being added at the end goes out first and the stack becomes like this. If you do a pop again on this stack, 2 comes out this time and the stack looks like this. And when you pop the final element, your stack is empty. Let's move to C# and see how this works out. So this is stack, right? So in C#, stack again is a generic type where you can actually pass the type of stack that you are creating. That means the type of data that you want to store in that stack. So now you create a new stack instance here, like the example which we just saw. I'm pushing 1, 2, and 3 here. Now what I'm doing here is I'm iterating through all the elements through the stack and I'm trying to pop them out as well. And I'm running until the stack.count is greater than 0. The moment the stack is empty, I come out of this loop. So let me put a breakpoint here and run this. So as you can see, it popped as 3, 2, and 1, right? Last in, first out. Okay. Now what I'm doing here is, since I've popped all the elements, the stack is empty. The count is 0. I'm pushing back again the same 3 elements here. Okay. 1, 2, and 3. Now the stack has again 3 elements. If you just click them, you will see at 0th location is 3, at first 2, and at index 2 is 1. Okay, in reverse order. Now there's a function called peek. So there are situations where you don't want to actually pop the element and then find out that you didn't want this element, right? So you can peek and check whether what is on the top of the stack. So peek gives you that functionality. Peek does not remove the element, but it just gives you the topmost element in the stack. Let me just run this statement and print. So here you can see top of the stack contains 3, right? Correct. So now we are popping that, but now if we pop it, 3 is now popped. Now if you try to peek again, you will see 2 because 3 has been already popped, right? So now you have 2 here. So now at this state, if we actually go and see the content of the stack, it has 2 elements, 2 and 1. 2 is still there because we peeked it and did not pop it. So that was pretty much about stack. We mostly use push and pop, and we use those in situation where we want a last in, first out kind of access of data. So the next collection type here is queue. So as you can see, we all know queue. We get into queues very often. So this is a queue of very tired people. But however tired or bored you are, you will have to follow the first in, first out driving principle of queue. Whoever is in the front of the queue gets served first. So now let's see how a queue works in programming. So queue has 2 operations, enqueue and dequeue. So enqueue, what it does is it actually adds an element to the queue. Like for stack, we had something called push. So here you add 1, the queue looks like this. You enqueue 2, 2 goes behind 1. And then you enqueue 3, 3 goes behind 2. Now when you dequeue, it follows the first in, first out principle. So it first removes 1, then 2, then 3. Finally your queue is empty. So now let's move on to C# and see how that is implemented. So in C#, queue is again a class which is a generic class that C# provides out of the box. Again, you provide the type of data that you want to store here. Here I'm enqueuing these three elements, 1, 2, 3, and I'm printing them one after the other. So when I complete and get out of this queue, unlike stack, you will see they are printed in 1, 2, and 3. 1, 2, and 3, right? Not 3, 2, 1, as we saw in case of stack. There's a small typo here. I called it popped. I should say it removed. So in case of queue, we don't call it popped, but we call it removed. So I just changed it here. So now we move ahead and we enqueue 1, 2, and 3 again here. Okay. And then we do a peek again. So peek is still there even in queue. So what it does is, again, it gives you the first element in the queue without removing it. We run till here and see what actually gets printed. So top of the queue contains 1 because we added 1, 2, 3 again. Now what I will do is I will dequeue one element here. At this point, we have all 3 elements. If we dequeue, 1 will be gone. So we do that. And then we peek again and we print. Here we go. We actually print 2, right? Because now 1 is gone, 2 is in the top or in the first position of the queue. So this was queue. Again, queue has enqueue, dequeue, and peek functions, and they have few other functions, but most of the time you'll be using these functions. So we use queue wherever we want a first in first out approach of handling data. Now let's move on to our last collection type here for today, and that is called dictionary. Okay, so in dictionary, we use dictionary all the time, right? And even Google provides a dictionary if you try to get a meaning of a word. So what does a dictionary do? Dictionary stores a key, right, or a word and a value of that word, which is nothing but a meaning. So dictionary is all about a key value pair. Okay, you have a key, which in case of this dictionary is a word, and the value of that word is nothing but the meaning of that word. That is what a dictionary means, a key value pair. Now let's go to C# and see how dictionary is used and where it is used. Okay, so here is a dictionary. So now, as I said, it contains a pair, right? A key and a value. So again, you give what kind of data you want to store. It's not necessary for the key and value to be of the same type. Most of the cases we declare key as a string because we want to access that using that string value. Value could be any type of data type. Here I'm using string. So what we do here is we create a dictionary instance like this, and then this is how you add elements to a dictionary. So dictionary.add method takes 2 arguments. First argument of this method is a key, and the second argument is the value. So here I'm storing username as John. So this dictionary will store a key value pair where the key name is username and the value is John. Same we do 2 other key value pairs, account name and created by. So let me run till here and show you how it looks. So now if we hover over the dictionary object, it has 3 members. You can see username John, username John, account name this, and created by self, right? So this has a key value pair. The key has the key name and the value has the value name. So now you can access a particular value of a key in this format. You can write the dictionary name, and like you used to access arrays with indexes, instead of the index, you can put the key name here and get that value here. Remember, the return type of this statement will be the type of the value that you have declared. Here it is of type string, so we are returning it to a string type variable called name. Okay, and we are printing the name here. Let me run this. As you can see, value of username is John. That's correct. So like other collection types, dictionary has a lot of other methods within it. Few of the common ones we will discuss here. The first one is contains key. What it does is it tries to find a particular key that you pass as an argument to this function and tells you true or false whether that key is present in that dictionary or not. Okay, So here what I'm doing is I'm trying to search for a key called hello, right? But that key does not exist. Now if I move ahead with this, you'll see it goes to the else statement. So it will print not present on the screen. Okay. Next method that we will use is dict.keys. Instead of a method, this is actually a property which gives you a collection of all the key names. There are situations where you want to iterate through all the keys just without getting their values. Okay, so this is how you do it, dict.keys. So I will run up till here and show you what it prints. So for all the keys, it actually printed the name of the keys. So here you can see username, account name, and created by are the three keys that we had added. Similar way, you can just access the values as a collection as well, where we do dict.values. I will run till here, and we should be seeing just the values here. So John, johnabc.com, and self. You can remove a value from a dictionary by its key name. Created by is the key that I want to remove. So it will remove this key as well as the value associated to it if we run this statement. So let's do that. Now if you go to dictionary and see the count, now it has 2 because created by has been removed. Okay, you can also dig in here and verify that. So you just have username and account name, created by is gone. So that's what we print here. We move ahead. The final method that we want to cover here is dictionary.clear. What it does is it actually clears the dictionary to empty again. So it will remove all the values that are stored in that dictionary. Okay. So if I run this statement now the dictionary is 0 count because all the elements has been removed. Now if we print this too, we will see the same on the screen. Okay, 0, no elements left. So guys, before we wrap up chapter 5 on collections, I wanted to talk about string and some of its unique characteristics and how they're related to collections. Okay, so strings basically are under the hood a collection of characters, right? So one string may have one or many characters to it. So in a way they are collections by their own, but you don't need to really create a list and store characters to build a string. But nevertheless, under the hood, they are collections of characters. Now, string has some unique properties, the way they are handled in memory, which you need to understand string as a data type even better. Okay, so even though string is a reference type, they act and behave like a native data type, like int, char, float, etc. Right? So we'll see how and why. So there are two terms that you need to understand when it comes to string. One is this immutable word, why it is immutable. The second thing is, and what is a string pool? Suppose I execute this line of code where I'm declaring string 1 with a value as hello. So what it will do is in step 1, in memory or in a pool, it will create a collection of characters and assign it to this particular variable. So this str1 is now referencing to a memory location where hello is stored. Now, if I write this string str2 and write str2 equal to str1, so basically what we are doing is we are storing this hello to str2 as well. Okay, so now str2 also points to the same memory location. Now, if we move ahead, execute this code where str3 is equal to hello world, str3 gets a new location where hello world is stored. Now the fun begins when you write this string str4 equal to str3.left5. That means I'm trying to take 5 characters from the left of str3. The moment you do that, right, even though you have not set str4 to str1 or 2, it finds that you are trying to store a string which is hello. So what the runtime will do, it will check in this memory pool, okay, or string pool, whether there exists a value which is called hello. If it exists, it will point you to that value, even though you did not explicitly set that, like here. you will still get the reference of hello. Now see, the problem here is if unknowingly you are sharing memory location or variables with other reference variables, the problem is what happens if I change this? Then these also gets changed without me knowing, right? Like for other reference types we have seen. To avoid that, strings are made immutable. So what I mean is, if I write this line after this where I'm trying to trim the value of str4 further, so from hello I'm trying to extract last two characters, it will not really go and change this value. It's checking. Now you want to assign he to str4, it will check in the pool, are there any he's lying here? No, right? So it will create a new instance of it and assign str4 to this. So now you saw this hello remains unchanged and str4 gets assigned to he now. Okay, and this linkage is gone. Now what if I go ahead and write this line of code, str3 equal to he? The moment I do that, right, I will set str3 to again he, because it finds he is there in the memory pool. So I will assign you this. Now these two are pointing to he, and this connection that we had for str3 previously, hello world, that is gone. So at this point, hello world is not being referenced by any variables, right? So this is eligible to be removed from the pool because no one else is using it. The garbage collector, which actually takes care of clearing up unused variables, will pick this and clear it up from the memory and free up that space. Okay, now let's move to C# and for real see whether this is happening or not. So here's a small snippet of code here. So the way we will verify this is using watches. So if you see, what I've done is in watch, I have added watch for these function calls. Okay, so get hash code is a method which is part of the object class. Okay, so any class in C# will have this get hash code. What it does is it gives you a identifier or a hash code against the reference or the actual memory location where the value is stored. Okay, so this will uniquely tell us whether they are referencing to the same variable or same location in memory or not. Okay, so for all of these I added hash code here. So now let's proceed. So see, str1 is now assigned to hello. I will just recalculate this. So this is the hash value I'm getting, ending 990. Now I will proceed further. So str2 equal to str1. Now let's see what this value gets. So you can see it's pointing to the same memory location, but this was expected. Now let's move on. Now I type str3 equal to hello world. So str3 will get a new location as we had expected. That is okay. Now what I'm doing is here str4 equal to str3.substring 05. So str4 we are storing hello. So hello is already stored in str1 and 2, right? So let's see what happens now. Here, if you see str4 and refresh, here you go. It gets a location which is already used by these two, right? And that is because the runtime found that it's trying to store hello and it's there already. Okay, so now let's move ahead and execute our next statement. So here what I did is str4, I'm setting it to he, right? So let me refresh this. Here you go. It gets a new location altogether. Now I'm setting str3 equal to he as well. So now str3 had this. Let me refresh here. Now you see it gets this location. So even though you did not say str3 equal to str4, because you set it to the same value as str4, it got the same memory reference. Okay. So what this means is if I stop this code and write this piece of code. Okay. So what I'm doing here, I'm creating a list of string and storing the same value, hello, 10 times here. Okay, so str1 has hello. I will print the location of str1 or the reference of str1, and then I will assign not str1 but hello 10 times. I could have done it 100 times as well. Okay, now for each element I will print the hash code. Okay, so let's see how it goes. I'll just run this. So str1 has a hash code of this, and each and every, because it's storing the same value as str1, all the elements of this list, it contains the same value. So even if you create 1000 element long list and store the same value, it's not going to consume more memory for you. And that is one of the key reason why string pooling is used, because string is so frequently used in our programs. It makes sense to share memory to actually use memory optimally, right? Without having too many duplicate strings in the memory. Hope that makes sense. With string completed, that is all we had for this lesson. We will move to lesson 6 and we'll do a little bit more deep dive on classes and encapsulation. Some of these we already covered in lesson 2. If you have not watched that, go ahead and watch that. But we will do some more deep diving into classes and encapsulation in the next class. So stay tuned for that. And as always, I would request you to kindly put a thumbs up to this video if you like this, and also subscribe to my channel and share it with your friends. Thank you very much. See you next time.